So we get to know about the charged particles that are actually the subatomic particles of an atom, and electrons and protons are holding the charged properties over them, and if they are moving, then we can say that the electricity is there. Okay, but how we can measure it? How we can measure the charged particles, that how much charge is present in any object? So what is the SI unit of electric charge mainly? Okay, that is coulomb, and it can be represented by capital C. Okay, so what is 1 coulomb? If somebody is going to ask you, okay students, let me tell you what is 1 coulomb. Okay, now if imagine that there are 2 electrons and these 2 electrons are having some charged particle over it. Okay, and the charge particle between them, if it is exerted like 9 multiplied by 10 to the power 9 newtons, the force of repulsion or attraction. If we are going to speak about electron and proton, let's suppose, so they will attract each other. Okay, like this, it is repelling each other with this force, and if they are attracting each other with this force again, and the distance between these two, like here also between the electrons, if we say 1 meter, and here also if we say 1 meter, then we can say that 1 coulomb of charge is present. Okay, but here this quantity is not enough to make the 1 coulomb of charge. Okay, why? Because these 2 electrons, single electrons on both sides cannot make such kind of force. That is 9 multiplied by 10 to the power 9 newtons. That is a very huge force of attraction. That is the very huge force. Fine. And here also in case of 1 electron and 1 proton only, this kind of attraction force cannot be exist. So the amount of electrons here and the amount of protons here, the amount of electrons here will get to be increased, and will get to be increased at such a manner that we will get such kind of force. So again, if now we are going to summarize all these things, so we can say that charge particle here and charge particle here, number of charge particle here and number of charged particles here, and the distance between them is 1 meter, and the force of attraction or repulsion, any kind of force I am telling about, is 9 multiplied 10 to the power Newton. Then we can say that here are 1 coulomb of charge present. So here is the measurement that we have told some amount of charge particles should be present that will exert 9 multiplied 10 to the power 9 Newton of force. What charge? How many charge we need to required? So let us calculate that also. Okay. So here are charge particles. You know that one is proton and another one is electron in an atom, and that proton is positive and electron is negative. That you have to make it remark. Okay. So both of these charged particles are having the charge quantity that is 1.6 multiplied by 10 to the power minus 19 coulomb. Okay, that is the charge amount that is present on a single electron, and that is the charge amount that is present on the positive proton. Okay, so now some students are having such kind of question that, ma'am, if both of these are having the same amount of charge, then why electrons and protons are distinguished? Why they are different then? Okay, let me tell you students, protons are having a positive charge and electrons are having a negative charge. And why they are positive and why they are negative? Because they are revolving in some direction and electrons are revolving in the opposite direction of it. That is why if we are considering that this amount is positive, so we have to consider this as a negative because it is revolving in a opposite direction of it. But the charge that they are holding, the amount of attraction that they are holding on a single one is equals to 1.6 into 10 to the power minus 19 coulomb. Okay, that you have to keep remember. So here's you know that 1.6 multiplied by 10 to the power 19 coulomb is a very less amount of charge, and we need to make it 1 coulomb of charge. You know that here is a symbol 10 to the power minus 19, and you got to know about it. In mathematics also you have learned that this is the reciprocal of 1 upon 10 to the power 19. Okay, that suggests you that 1 divides itself into 10 to the power 19 parts. That is, if we put 19 zeros in front of 1, that is how we going to divide 1. That is too small value, dear all. Yes, so how does it make one number itself? Complete 1 also is not possible here in this case. That makes us to know that too much amount of charged particles we need to make one number, that is 1 coulomb. Yes, so number of electrons required we don't know, and total charges here we need to make is 1 coulomb actually. Okay, and so how we can do that? We can simply multiply the number of charges, how many charges are present, and the charge on a single electron, that is 1.6 multiplied by 10 to the power minus 19. If we multiply this single charge quantity to the number of electrons and make it equals to 1, so we can find the value of number of charged particles, that much of charged particles required to make 1 coulomb charge. So yes students, we need to do little math here. Here we know that the number of electrons required we need to find, and we earlier got to know that total charge is equals to number of electrons required multiply by charge on a single electron. Okay, so here if we need to find this value, we need to make this to this side. Okay, we need to shift this thing to the next side, and that will going to divide. You know that if something is multiplying here and after changing the side of the equals to, then it will change its sign also. Okay, so here I have already written it for you that the number of electrons required here will be the total charge divided by the charge on a single electron, and you people know that the charge on a single electron is 1.6 into 10 to the power minus 19, and total coulomb we need to find is 1 coulomb actually. Okay, so let's do some mathematics here also. Okay, so if we bring that 10 to the power minus 19 to the upside here, that will become positive 10 to the power 19, and replacing it with 10 multiplied by 10 to the power 18, because you have learned in mathematics also that any base, if you are having a similar base and different power, then you can add these two numbers. Okay, like this, am plus n. In the same manner, if it is written 10 to the power 19, so you can write it like this also, 10 multiplied by 10 to the power 18. Am I right? Yes. So dividing it with by 1.6 here will gives you the value of 6.25 and multiply by 10 to the power 18. So here is the number of electrons that we got, that is 6.25 10 to the power 18 number of electrons. I have told you now that too many charges are required to make 1 coulomb charge, and 1 coulomb charge is not a very small amount, that is a very big amount. So here is the number that we require charge particles.